Hello, this is the lecture for manufacturing systems. In this lecture, I want to talk about several different aspects, starting from physical components like devices, sensors, motors, and also transportation equipment, inspection devices, as well as storage methods in production systems. And then we'll talk about different production planning and control methods like process design, layout design, scheduling, material requirement planning, inventory control, and quality control. And these topics are mainly going to give an introduction. And if you want to get into a little more depth, then we'll have another course, ISAT 330, manufacturing system, sustainable manufacturing systems, to learn more about each of the topic. So this lecture is more like a survey of these topics. Well, first start with some physical equipment in the manufacturing system. The first one is a machine. CNC machine is a very common machine you will see in manufacturing companies. The full name for CNC is computer numerical control. So basically, it's to use computer to generate programs so that all the tool cuttings, all the tool passes will be automatically conducted instead of manually operate those machines. And how does it work? We're going to start with the 3D model. First, you design a 3D model in the software, and then the 3D model will be generating NC program. So this kind of process is called computer-aided manufacturing. Well, what it does is a computer program will generate the tool paths, how the tool will move to cut the materials based on the 3D model. And then the result of the CAM is the NC program. So NC programs are the series of commands, and as you can see the G code to the right. And so these are a series of commands that will tell the CNC machine tool of what to do. For example, going to the left, going to the right. Of course, it's all based on the coordinate system, X, Y, Z. And this is how the CNC works. And sometimes you can see a CNC milling machine, CNC lathes, or some other CNC centers, depending on the process itself. And you can watch the video of how the CNC works in the link with the slides. Another major component of physical things in manufacturing is sensors. So the sensors are devices that we can collect the information from the production, and especially for production line, you actually need a lot of data collection, as well as using the data for decisions. For example, sorting different materials, or checking the quality or counting. So these all need sensors, and there are different types of sensors. Depends on what is use of it. For example, in our life, we see all the different sensors, distance or versus some other things, and we can categorize those sensors as in the following categories: mechanical sensors, for example, position sensors, the velocity, force, and torque, or electrical sensors, thermal sensors, magnetic sensor, light sensor, one of those. And what I will suggest you to do is to go to search all these sensors. How does it work? And in our assignment, we'll also give you different sensors, and you figure out how these sensors are actually designed, how do they work, and what are the applications. When we get into it more technical, we need to understand how these sensors are actually designed. And next one is the actuators. So sensors are those that we are collecting the information. Well, the reason we need to collect the information is because we want to give the system a certain feedback. So the feedback will be some physical feedback, that is triggered by the actuators. Actually, actuators are it can be electrical actuators, Usually these are motors, either step motors or solenoids, or some other type of actuators will be powered by hydraulic power or pneumatic power. And there are also two videos you can look at about what kind of motors and how the motors work. So these are three different power source or type of power for the actuators: electrical, hydraulic, and pneumatic. And you will see that used very often in production companies. So hydraulic ones, typically you need, they requires higher power for the process, then you can consider hydraulic. Electrical one, they sort of has certain limitation. Same with pneumatic. Another type of devices will be interface devices. So interface device means that we need to convert the information, from signals to digital numbers, then from digital numbers to signals as well. And that's why we need those interface devices. And from analog to digital means we collect the information from electrical signals, right? Electrical signals that is happened on the production line. And then the electrical signals will be coded and then converted to digital numbers because computers can only deal with numbers, right? So that's why we need this, ADC device to help us do this conversion. Well, on the other hand, if after the computer deal with the data, then we have to give some certain output to the system. So which means that we need to convert those digital data to electrical signal. Then we need a digital to analog converter, DAC, to do that. And also, we will certainly need, certain contacts to help, in between of the interfaces. And I'll give you one example of the ADC and the DAC. For example, we are recording a song, a music, right? So we have those voice moves in the air, and then what happens? Those moves will, with those waves, will be converted to electrical signals, right? Electrical signals will be converted again to the digital numbers. Then we can edit all these sounds in the computer. After we added those computers, what we do is we use this digital to analog converter and convert it back to electrical signals. This is the sound what we hear, right? So this is how the ADC and DAC works. Another type of the automation devices you may see is PLC. So a full name for PLC is programmable logic control. What it does is it uses certain logic to control the automation. Let me give you an example. Say if I lift my left hand, the door will open, right? If I lift both of my hands, the door will be closed. So something like this. Then I lift my left hand, and then you will see the door open. If I lift both hands, then you will see the door is closed. So like those logics, and PLC, the program logic control, are using those logics to control the automation. And of course, when you program one of those, especially when you involve a lot of sensors, when you involve a lot of actuators, and the logic will can get a little bit more complicated in programming. But it has been very powerful and useful in production companies. Depends on the purpose of the application. Maybe you can do a very simple logic to control automation, it all works, or sometimes it may involve a little bit more complicated programming. I suggest you watch this video in a slide, look at how the working mechanism of PLC. Another type of machine, of course, is industrial robotics. As we know that, in the future industry, now we are all moving to the robotic operations instead of having human workers. There are several different benefits of using robotics. First, it's very consistent. because it's all programmed, it's very accurate. While human labors, might not be as consistent as robotics. So, and also, robotics can never get tired. So, right, they can work 24 hours a day, but human worker has to, have a rest. So that's some place. That's the reason that people prefer to use industrial robotics. Another type of application is when we need some really hazardous environments, right, or dangerous environments, we will use industrial robotics instead of using using a human worker because of the health concerns. And please watch this video and see how these industrial robotics actually used in industry. Next one is the different transportation methods or equipment. One is conveyor, or one category of those transportation is conveyor belts. You have seen a lot of conveyor belts, right? For example, if you go to an airport, right, where you claim your luggage, and you'll see the conveyor belts actually carrying your luggage around and to pick up. And similarly, we can use that in production companies as well. And people have developed different ways, different versions of different types of the conveyor belt. And you can all see that through all these videos. Make sure you watch all these videos on slides. Okay. Another type of the transportation vehicle is it's called automated guided vehicle. It's called AGV. So AGV is very similar to those autonomous vehicles that no one is really operating it. Instead, it just use program passes and go places. And so and there are different technologies for AGV. So, for example, you can use AI to program it, or you can use some developed paths to do it. Sometimes you can see that there are tapes, right, on the shop floor, and then the AGV just follow the paths to do that. And yeah, so that's AGV. It's been very widely used in production companies now. Another one is crane and hoist. What do we use? Typically, we use them to lift things and move from one place to another, especially for those heavy materials or heavy equipment or some other heavy devices. We use crane and hoist. And for inspection, so there are typically two types of inspection devices. One is contact ones, another one is non-contact. So contact ones, some of you are pretty familiar, like gauge, we did that in the lab, caliper, micrometer. There are also another two examples. One is the stylus electrotonic instrument. So this is to measure the surface roughness. And please watch the video and see how the device works. Basically, you have a probe, so you can actually scan the surface, and then based on the up and downs, very little waves, it will generate different waves on the graph. And then this is how you can tell the surface roughness. Another device is equipment is CMM. So full name CMM is coordinate measuring machine. In the next slide, I'll talk a little bit more about that. And another type of inspection device is non-contact ones. So non-contact ones typically use a sensor to measure the features of a product. And comparing the contact and non-contact ones, non-contact typically do not have to touch the surface. So it means that there's no way you can do damage, right? Or you can avoid damage to the part. And also, it does not require special positioning of the part or removal from the production line. But if the contact one, you have to either remove it and then measure it with your hand. So that can be a little bit more time consuming. And non-contact ones, typical equipments are lasers, or machine vision technologies. So lasers basically use the light, traveling the light to measure the distances and also to measure the variations of the features. Well, machine vision basically are using pictures to tell the differences. So, of course, the other technologies other than optical, some non-optical ones will be in some electrical field techniques, radiation or ultrasonics. CMM is a type of machine that you can actually measure the dimensions and then calculate the differences between the tolerances or defined dimensions of the model with the product dimensions you made, and then calculate the difference. If it is the difference is out of the control or out of the tolerances, then you see there's a problem with the part. But if it's all within the tolerances, then you are good. So this is how the CMM. So when you're using CMM, first you need a 3D model, no dimensions, and then the machine itself will, using the probe and to touch different places of the part, and then to basically to create another model, and then compare the two models' dimensions. Please watch this video and see how the CMM works. And for storage, and there are some traditional storage technologies as well as automated storage technologies. Traditional ones will be, we just put them together as a whole block storage, right? It's high density ones you'll see in the picture A. But for picture A, there's a problem is that it's hard to access the middle the products or inventories that are in the middle. Well, you can use the second one, which is develop some rules, and then you can easily get access to the middle of the inventory storage. Of course, you can use this rack system and shelves and bins. This has been very popular as well, and we are actually using this for in our manufacturing lab. Cabinets for some smaller tools, and well, if it is automated storage system, typical one will be ASRS. So it's called automated storage and retrieval system. A lot of libraries and also some other inventory companies actually have been using this ASRS system for receiving and retrieval. Please watch this video and see how it works. Well, now let's get into our second part of this lecture, which is production planning and control. And first one is process design. So there are different types of the processes, as we discussed in our first lecture. It really depends on what kind of product you're making food or making rockets or making cars. The process can all be different. Now let's look at what are the categories. The first one is a project-based. So for example, this bridge, right? So if you are making if you're having really large projects like a rocket or airplane, or some maybe luxury cars, and typically you probably want to build the process around the product instead of having to move the product here and there, because either it's not convenient or it's too expensive to move those. And so that's project based. We organize resources around the product itself to make it. Another one is job shop. So job shop means we are actually we have several processes. For example, machining, then bending, and then welding, and then assembly. For each process, there are multiple machines, right? For each process, there are multiple machines. Like in machining, I have machine 1, machine 2, machine 3, machine 4, right? Well, in the welding process or bending process, sorry, then I also have some bending machines, bending machine 1, bending machine 2. Well, in the welding, I may have welding center 1, 2, 3, 4, 5. So this is the job shop. So when order comes, I can choose to go to maybe machine 1 and then bending machine 3, and then welding center 2. So from a pass. So it really depends on the machine's capability and also capacity. And another one is the production line. In those cars, right? You will see, it's a production line. We have the products or the part travel from one process to another process, and for each production, we typically only have one machine. Sometimes we may have multiple, but overall, it forms the production line. And another one is a batch production. So batch production means for each setup, we are not only producing one product, but we're actually making a bunch of those parts. For example, in the third picture, as you can see on the tray, there are actually we make several parts together. But the problem with batch production is that there will be a lot of waiting time, especially when the center or when the process can only process one at a time. Another one will be the continuous production. So continuous production means there won't be any wait production. Typically, they are used in food production or liquid type of products like gasoline, right? So those are the continuous production, and means the process no stop, keep flowing, and you don't really see a certain batch. So that's a continuous production. And when you are designing a process, there will be several considerations you need to think about. One is production volume, right? Say if you are making 1,000, right? If you are making 1,000 parts a day, then product basically probably not a really good choice. Maybe a production line will be the better choice because it will make the cycle time a lot smaller. And so production volume is one factor in process design. Another one will be the cost and the revenue, right? So in some of the processes, the cost will be a little bit lower. Sometimes the cost will be a little bit higher. And then what you want to do is to find out a break-even point where you can generate revenue with lower cost. So like the graph is showing. And this is what you need to consider when you are designing a process. And we're designing process and also doing some process analysis. One thing that we are doing is to draw a process flow chart. And process flow chart is typically composed of some chart symbols as well as arrows. And symbols, as you can see on the slide, some are squares, some are cylinders, some other shapes, and they all they all means different kind of activities. For example, a circle can be an operation, an inspection. You can use a square, and then you can use the arrow to show the transportation, and delay with that shape, and then storage with that shape. And then in your process flowchart, basically you are using those symbols to signify the processes. Also, you can use the flowchart symbols from the right. For example, the decision, what kind of shape it is. And this is an example, for a process flowchart. When you start to get up, and then here the alarm rings, and then you start to make a decision, with that. Are you ready to get up yet? If it is not, then maybe you can hit the snooze button, and then to have a delay and an alarm, rings again, and then later you make another decision. If you're ready to get up, yes, then climb out of bed and then end. So this is a show to use a process flow chart, either to show some process or show some logic. And this is another example that is showing for process flow chart, especially for manufacturing shop floors. So this kind of sheet typically happens in a manufacturing shop floor. On the left, you can see these are different operations with different type of operations, like operation, transportation, inspection, delay, and storage. And you can use those arrows to connect all of those. And so on the right, you'll see these are descriptions of the process, including the time of the process, as well as distance from one to another, or distance of the travel. So this is more common to see this type of the process flow chart in manufacturing shop floor. In terms of the layout, there are several different types of layouts. One is the office layout. So office layout, basically, as you can see in either in a bank or in some office areas, see how the different stations, how different desks are actually arranged. Well, another is process layout. Process layout means we are actually organizing the products or organizing the equipment processes based on the process flows, right? That's process layout. Sometimes you can also see the product layout. For example, it depends on what product you're making. For example, some car companies, right? And you may one line may be producing one model of the car, right? For example, Toyota Camry, or maybe a Toyota RAV4, right? This will be another production line. So this is how they can organize their layouts. Another one, of course, is the warehouse layout. So basically to organize those different processes based on based on what is available and how to retrieval, how to receive. And in the layout, there are considerations. We are designing layouts. The considerations will be, think about what a resource you have, what kind of space you have. The resource means how much maybe money you need to spend, as well as how much material gets supported. And the space means not only it's how much is the space, but also what is the shape of the space, because they all can affect your layout design, as well as safety reasons, cost, process flow, functionality, etc. And another diagram we typically see is the precedence diagram. So precedence diagram describes the relations between the processes. For example, we can start from a very raw material. Then in order to make the finished product, we need to go through multiple processes. Then how all these processes are related. You can see, for example, in this one, after the raw material, it actually will go to two separate ones. Either go to A or go to B. And then in the end, when it reaches the EF, you can see that's probably more an assembly process where you combine E and F to be your final product. So this is a precedence diagram. Typically, when we're drawing a precedence diagram, we also will put the cycle time on it, right? Make sure when you draw a precedence diagram, add the time, cycle time on it. And this is an exercise to do the precedence diagram. I already showed you this table. It shows the different tasks from A to K, and also task times, like how much time it requires to finish the task, including the description. And also the relations between the tasks will also be given, right? Tasks that must precede. And you can read this and then do this exercise by yourself, and then draw a precedence diagram. make sure you put the task times next to the process. Okay. Another topic in production planning and control is scheduling. So scheduling means when we receive the order, we need to make a plan that how fast and when should I put on the line and how fast it can produce, it can process, and when it can be finished, right? And so there are many ways of doing scheduling. One is infinite loading. Infinite loading means we can put an order on the production line whenever is needed, because there's we do not have to consider any capacity issues, and there's always capacity on our production shop floor. Well, finite loading means we schedule our orders based on the resource we have. Well, the resource can be maybe the availability of the machine, maybe the human labor, or maybe some other factors. And for the finite loading, we can determine what will be done by each resource at every moment during the day. Another type of the scheduling is a forward scheduling. So forward scheduling means we take an order and we can see what is the fast time I can put it on the production line, and then it can be finished, right? So from the forward scheduling, we can tell the earliest date that order can be completed. Because whenever the line is available, I'll just put it on the line. Well, another one is backward scheduling. So backward scheduling is more of a starts with a due date. For example, we have an order, and that is due, say, end of November. Then, starting from end of November, we can calculate, okay, what is the latest time I can put this this order on the production line. It's like a homework, right? You foresee that this homework will require 3 hours and it is due tomorrow midnight, and then you can tell, okay, 3 hours due tomorrow midnight, maybe the least time I can start my work is actually 9 p.m. But do you really start from 9 p.m? Probably not, right? So that's back how the backward scheduling works. You can tell what is an order must be started in order to be finished at a specific date. And when during scheduling, there are different type of the limitations. One is the resource, like machine resource limited process. Another one is the labor limited process. And of course, when we are doing scheduling, they are based on the order types. You can use different rules. First come, first serve, shortest operation time, earliest due date, critical ratio, last come, first serve, random. All these different rules you can use for scheduling. It's not always first come, first serve, but it also depends on the importance of the order, size of the order. There will be a little bit of flexibility you can use. Maybe do a combination of rules. Another topic I'm going to talk about is material requirement planning. So material requirement planning, but basically it's a logic, right? It's a logic for determining the number of parts, components, materials that needed to produce a product. How to explain this? For example, if you are, let's use this example. If we are ordering, right? All the factory receive the order that need to make 900 matrices in a month, right? And then based on this amount of order, then I know what kind of subcomponents, what kind of parts do I need, right? What kind of part do I need? I don't need all the parts to be here at the very beginning of the factory or at the beginning of the production, because if some of the parts maybe I only need it at the end and the last process. So all I need to do is when my process comes into a certain step, then my parts arrive. right? If I can schedule that parts arrive at the exact time I need it, then I will reduce the waste, because you don't want to spend a lot of space, a lot of time just to deal with inventory things. So that's why we need material requirement planning, to let the material arrive at the right time, the right quantity. All right, and so the typical applications of MRP will be is mostly useful or valuable to assembly operations, because assembly operations usually involve a lot of parts, right, to be there at the same time. But it's least valuable to fabrication, because you do not have a lot of parts and it also outsourced from other places, other suppliers. And it's also very valuable to industries, where a number of products are made in batches using the same productive requirement. And it's not so valuable to those, high producing complex, expensive products requiring a lot of, design and research. I already talked about this example, and then next will be the inventories. And so we talk a little bit about inventories. We mentioned that you probably do not want to have a lot of inventories, because inventories are those that does not really generate value in it, right? What are inventories? You put things on the shop floor without moving it. If you are not moving it, means you are keeping the cash or the money on the shop floor, and it's not generating value for you, right? See, the inventories are the cash, are the money, and what we want to do is we want to let the money flow. Otherwise, if you have all the things embedded into the inventories, then you'll see a cash disruption, right? And then there will be some other issues. So what type of inventory can we have? Typically, inventory happens in raw materials, where you get raw material from your suppliers, and also it can be some outsourced manufactured parts, right, from our suppliers, or it can also be some sub-assemblies. For example, we already been through some of the processes, and we got some sub-assemblies, and then the next process is either it is experiencing a queue, or something happened that we need certain waiting time, or maybe a lot of extra, right, that is not really needed. They all can be inventories for sub-assemblies. And of course, inventory can be the finished products, right, where you made all the products, but it's not sold yet. Right? And you can tell all these money are in those inventories, right? And if you don't sell it, you cannot get the cash back to you. If you do not get the cash back to you, you cannot purchase the raw materials, you cannot let all the parts flow on the shop floor, and won't be any benefit from you, right? So that's the importance of keeping the material flow on the shop floor. And inventory as a typical way of hindering that kind of a flow. But it does not mean that we never want inventory, because some inventories can actually help make the process more smooth. So think about if there's a production line and some processes are experiencing a lot of delays. Well, if you already have some of the inventories or semi-made products from that process, or parts from that process, then you can just use inventory to keep the production line flow, and then you can see problem solved, and you can keep making new products. Otherwise, maybe the whole production line will have to stop, and then you won't be able to make any products. So sometimes the inventories can help us to smooth out the barriers. And some other purposes for inventory will be meet the variation in product demand, allow flexibility in production scheduling, provide safeguard, right, for raw material delivery time. Also, you can take advantage of economic purchase order size. So basically, the more you purchase, the lower price of the materials. And different categories of inventories, pipeline, stock. So those inventories are those, in process, in transit stock. And for example, some, semi-made products, semi-made parts, right? It can be pipeline stock, or it can be, cycle stock. Those are like batch production, right? You have to wait until you become a batch to move forward. And also sometimes be the seasonal stocks, a time varying requirements of item. For example, if before summer comes, you probably want to store some more summer clothes, right? So when you get into summer, you got you have enough products to sell. And sometimes some stock can be the safety stocks because of the supply chain, uncertainties like chips, right? If you have enough chips now, then you can sell your products pretty well. But what happens is there's a shortage of chips, and then all of it's hard to buy products now. And also, there are some other reasons for you can hold stocks. For example, decoupling of the stages of the production, like I just mentioned, explained how to smooth out the imbalances of the process, and price, quantity discounts, and all speculations. For example, the gas station, gas price going up soon, and then you may want to store a little bit more inventory in your car so that you don't buy the gas too expensive. And there will be cost of inventories. So the cost is not just the material itself. It's also, it happens in the procurement cost. For example, you are purchasing those, ordering those, set up the orders, receiving those, they all be cost. The cost can be the time of the labor, right? For example, you need an employee to deal with all of those, and that is the cost. Or some other things, maybe occur in the procurement. And also, when we are having the inventories, there will be costs associated with the existence of inventory. For example, holding it, right? We need space. We need people to handle it. Insurance, tax, all of those. And another type of cost that will be the setup cost. Setup cost means arranging specific equipment setups, filling out the required paperwork, and moving out of the previous stock of the material. And if there's a shortage of the inventory or shortage of material, you can, as you can tell, you may lose profit, lose opportunity, or lose customers, and also you may have some penalties due to the back orders. And so when I talk about the inventory, there's one principle when I talk about is Pareto principle. So which means that the few is typically have the greatest importance, and the many may have very little importance. And this can also use, we can use this ABC classification. For example, if we are looking at a dollar, typically we can see that very few parts actually have over 90% of the total cost of the product. Think about your phone, right? Maybe there are only some very key components, but like your screen is one of those, right? And the chip, the board is one of those. Camera is one of those, and these are the key components that are really matters, really more expensive in the dollar value. In terms of other screws, other things, other little components, maybe not that high value, but they're also needed, right? And so that's why people use this ABC to categorize all these inventories with high dollar volume, moderate dollar volume, and low dollar volume. Another way to categorize those inventories is the VEV, so which means vital, essential, and desirable. So typically it depends on the functionality of the parts. And another way is FSN, so the fast moving, slow moving, and non-moving. Some of the inventories might go away very fast, then we need this kind of constant refill of the inventory. And some products may not move that fast. Maybe only use it every every 2 or 3 months. Then that's got very slow moving or non-moving products inventories. So lastly, I'm going to talk about a little bit about the quality, because later we'll have a whole lecture just to focus on the quality itself. And we're talking about quality. The first definition of quality is totality of features and characteristics of the product or service that bear on its ability to satisfy given needs. This is defined by American Society for Quality. And we are looking at a product, right? In the definition, it's not just talking about product, but also a service. But in our lecture, typically we're focused on a product. So when we're talking about product, there are 2 aspects of quality. The one is product features. So product features comes from the design department, right? So if it is some design defects, then that's typically where it's a product feature problem. Well, another type of the quality is the freedom from deficiencies. So which means that, okay, the product design is no problem, but when I'm manufacturing it, when I'm making it, I'm not making the product or the part according to the design, right? So that's the second aspect of the product is deficiencies, freedom from deficiencies. Typically, the manufacturing department will be responsible for that. And there will be cost related to quality, of course. Something you can imagine will be, okay, if some is some product got a problem, then you have to spend money to deal with it, right? But actually, the cost for for quality really comes from different types of costs. We can use this chart to describe that. One is appraisal cost will be the cost for inspection and testing to ensure the product or the process is acceptable. So the quality control is really not just the last process to check if the product is doing well. It's actually embedded in every aspect, every process on the shop floor, right? So the appraisal cost to ensure the product process is acceptable through inspection and testing. Also, there will be a prevention cost. Prevention cost can be, to do all the activities to avoid those defects. For example, identify the cause of the defect, train personnel, or redesign certain products. So these all needs people to put time on it and put resource on it, and that is prevention cost. And also, there another cost will be the internal failure cost. So those are the costs that we notice or we found those defects within our production system, and then we do either put them in scrap or rework or do repair, and of course we need organized people, resource, and time, money on it to do all this work, and that's cost. Because if it doesn't happen, then we can use all these resources to generate more value, right? So that's internal failure cost. Another, we have internal, of course, we're going to have externals. External means those kind of defect products actually slip away from our inspection and without to the customers. Then it can generate more serious problem, which means you have to do maybe some recall, doing the warranty, replacement, or handling some complaints or hurt your reputation. Then that's a lot of other costs can be associated with those. All right, so that's everything for today.